In this video, we're going to talk about conditional probability. The definition of this term is the probability of an event A given that another event B has already happened. The formula that needs to be used for this type of problems is to divide the probability of A and B divided by the probability of A.
In the second problem, it says that Mr. Jones classifies his 570 coins based on their origin and the year of their creation. And they provide us a table that summarizes some of his findings, but it is enough to complete all of the information. So we start to add all of it up. 70 plus 80 is 150, 30 plus 140 is 170, 100 plus 150 is 250. And now we add the centuries, which is 70 plus 30 plus 100, which is 200, and 80 plus 140 and 150 is 370. And that all sums up to 570 coins.
Look for the problem says to look for the probability of the coin being American. So we look how many coins are American, which are 200, over the total of coins, which is 570. And we divide that, and the decimal we get, we multiply times 100, and it turns into 35.09%. And then we have to look for a coin that is American, given that it is from 18th century. And that is where we use the formula that we are presenting. And we have to multiply the probability of 200 over 570 times the probability of the coin being from 18th century, which is 150 over 570. All of that dividing by the probability of the American again, which is 200 over 570. What you get, you turn into a percentage, which results into 26.32%. And thus, letter C says that a coin has to be Canadian, given that it's from 19th century. So we use the same formula. We do the probability of it being Canadian, which is 370 over 570, which is the total, times the probability of it being from 19th century, which is 170 over 570, all of it dividing by 370 over 570, and the total is in percentage 64.91%.
We interviewed 100 students at Prepa Tech and we asked them which language they were taking, and these are the results we got. Before answering the questions below, we decided to make a Venn diagram. We decided to start with a 4 took all 3, which we put in the middle of the Venn diagram. 6 took French and German. From those 6, we subtracted the 4 that was in the middle and it became a 2. We did the same thing with the 10 took Italian and German and it became a 6. 9 took Italian and French and we subtracted the 4 and it became a 5. Now the middle part of the Venn diagram is done. To get the exact number of students who only took Italian, French, or German, we used the first 3 numbers that we got from our results in the interviews. For example, to get the exact number of students who only took Italian, we took the 28 and we subtracted it by the 5, the 4, and the 6, which are the numbers at the middle, which represent the number of students who took Italian and any other different language. We did the same thing for German and French. We subtracted the 31 who took French by the middle numbers, which were 5, the 4, and the 2. And for German, we subtracted the 42 by the 6, the 4, and the 2. So we got a 13, a 20, and a 30. To get the number of students who didn't take any of these languages, we subtracted the 100 from all the numbers in the Venn diagram and we got a 20.
So in this first problem, the probability that a student takes French and German given that he took Italian, we look at the Venn diagram and see where French and German together coincide with the people who took Italian, which is that 4 in the middle. So we write 4 over, and then we're gonna put it over 28, which is the amount of people who took Italian, because it says given that. So now if we simplify that, we get 1 over 7. In problem number 2, the probability that a student takes French given that he took German, we look at the two parts where people who took French also took German, and that's that 2 and that 4. Together it makes 6, so we put that 6 over 42, which is the amount of people who took German, and when we simplify, we get 1 over 7.